Okay, welcome back to another session of engineering mechanics. First of all, I would like to revise the topics which are covered in the previous class. Then we will start some new topics. Okay, in the previous lecture, we have completed few basics of engineering mechanics, like what is engineering mechanics and how the classification was done, what is statics, what is kinetics, kinematics. This is all about the classification of engineering mechanics. And later on, we have completed what is a force, and in order to characterize the force, what are the various parameters we have to consider. All these topics which were covered in the previous class. Okay, today we are going to discuss few other topics, few other basics in engineering mechanics, uh, like what is principle of transmissibility, and what is the parallelogram law of forces, or nothing but vector addition of forces, and what are the different types of system of forces which are available. Okay, today we are going to cover all these topics. Let us see one by one in detail. First of all, in the previous class, we have ended our class with force, because here force is the major parameter play which is playing a crucial role, because here force is nothing but which is the interaction between two or more bodies. In the last class already I have explained everything about the force by taking some examples. Then today our topic is principle of transmissibility. Okay, our topic is okay. Today our topic is principle of transmissibility, which is very very important in engineering mechanics, because this particular principle states that okay, let me take an example. This particular principle states that, okay, when a force is acting on a body or on an object in a particular direction, at a particular point, then even though if you shift, or even though if you move the same force along the same direction, okay, along the same direction wherever you want, it is does not going to change the external effects of the body. Okay, clear? Okay, here this particular principle states that when a particular force is acting on a body, here, in order to explain this particular principle, I have taken a block which is kept on a ground. Here I am offering some amount of force. Okay, here I am offering some amount of force. Here F is nothing but the magnitude of the force. Here F stands for magnitude of force, and here the force is acting over this block. Here the force is acting over this block at this point. This is the point of contact, or this is the point where the entire force is exactly concentrated. This is nothing but point of application. Point of application. Okay. Okay, the green color dot is nothing but point of application, and here capital F represents the magnitude. Okay, this is the magnitude of force, and this is nothing but line of action. This is nothing but the green color dotted line represents the line of action of force. Nothing but this is in this direction the force is acting on the block. Okay. Then according to this principle, even I shifted this force to somewhere. Even I shifted this force to somewhere along the line of action. Then I want to shift the same force. I want to shift the same force. Okay, let it be A. Now the same force is shifted to the point B, but the magnitude of the force will be remains same. The only variation is, as of now, the force is acting on the block at A, but now it is shifted to the point B along the same direction. Okay, when the force is acting at A as well as at B, it should be in the same direction. It should be along the same line of action. This is called as line of action, or which is also known as direction. Okay, either it is acting at A or it is at B, but still it is in the same direction, but the point of applications are different. Okay, in the previous case, the force is acting on the block at A. Now it is acting at the block B. Okay, let us consider the external action, or let us consider the external response of the block as a result of this force. Okay, when the force is acting at A, when the force is acting at A, it will try to displace the block. It will try to displace the block along this direction. Yes, sir. But it may be a pushing force. Here the force is acting towards the body, but always it will try to displace the block along this direction. Okay, when the force is at point A, but whenever it is shifted to the point B, but still there is no change in the external effect, because even though the force is acting at point B, but still it is trying to drag the object. Here it is pushing the object or pushing the block along this direction, but along this direction, even after shifted it to point B, still it is going to drag the object along the same direction, because at A and B, the magnitude does not change. Therefore, the amount of displacement taken by the block when the force is acting at A as well as when the force is acting at B will be remains same. Okay, clear? Not only the displacement, if the block is traveling with some velocity due to this force, then the velocity or the acceleration, whatever the external parameters or external effects we have considered, almost all external effects is same. Still the force is acting at different points along the same line of action. Clear? This is what exactly the principle of transmissibility. Okay, which is very, very important. Okay, in the coming classes, we are going to see how this particular principle is utilized in our regular problems, because everywhere we are using a transmissibility in order to simplify our problems. Okay, when we are discussing the problems, there you come to know what exactly it is, how we have to use the principle of transmissibility. Everything we will discuss during the problems. Okay, clear? This is what about principle of transmissibility. But here, if you consider the internal effects, nothing but in the previous class I said that when any object or any body is subjected to some external loads, there are two different responses. There are two different effects. Okay, the first one is internal effects and the second one is external effects. Then what are internal effects and what are external effects? Here internal effects are nothing but the effects which are produced within the body. The effects which are produced within the body as a result of this external load, they are called as internal effects. But in engineering mechanics, our discussion is only about the external effects, because here we are assuming that the subject, the body or the object what we have taken is a rigid body. Then whenever we consider the body as a rigid one, we need not to consider the internal effects. Clear? Our discussion is only about the external effects. External effects are nothing but the displacements or the velocities or the accelerations which are happened or which are produced in the body under the application of external loads. Okay. Here in mechanics, only we are going to concentrate on external effects. There are some other subjects like strength of materials and mechanics of solids and design. Some other design subjects are also there where we are going to concentrate on internal responses or internal effects. Clear? As of now, our discussion is only about the external effects. Okay, again, when we are discussing the external effects, even though you have shifted the force anywhere, even though if you shifted the force anywhere along the line of action, it does not change the external effects. Okay, even if you push the block at point A, or even if you pull the block at B, still the body is going to displace with the same manner, in the same rate, as well as the velocity and accelerations of the block are also same. Therefore, there is no change in the external effects, but the internal effects might be different. When you are pushing the block at point A part of the block may be under compression, because of this pushing force. If the same force is shifted to the point B, now it is acting as a pulling force. As a result of this pulling force, the block may be subjected to tensile stresses. That is a different issue, because here our main concentration is only about the external responses. Then we need not to bother about the changes that are taken place within the body. Clear? This is what exactly about the principle of transmissibility. Okay, and the next topic is, and the next important topic is system of forces. The next topic is system of forces. Okay. Next topic is system of forces. What is a system of forces? Okay, as of now, when I am explaining about classification of mechanics and when I am discussing about the force, and just now we are discussing, just now we have discussed about principle of transmissibility. Everywhere we have taken only a single force. But when it comes to the field, when it comes to the practical conditions, where almost all the objects or almost all the bodies are experiencing multiple number of loads. Clear? Let us take an example. Like if you take a building or if you take any machine. Okay, when we are producing some products by using a machine, where the machine is subjected to multiple number of forces, where we cannot expect simply there is only one force. Okay, whenever we consider any practical condition, everywhere, in most of the cases, almost all the objects are subjected to, almost all the objects or almost all the bodies are subjected to multiple number of forces. Clear? Okay. When we are taking the example to discuss some topic, we may be taken only one force, but when we go to the field, we don't have that chance. We don't have a chance to limit the forces. Only these many number of forces has to act. Like that, we don't have a chance to limit the forces depending on the task that the machine or the building is performing. In most of the cases, multiple number of forces are acting. Clear? Okay, when let us take an object which is having a multiple number of forces. Okay, now in this case I have taken an object having around 1, 2, 3, 4, 5. Okay, here the body or the object is subjected to 5 different forces. Now here system of forces is nothing but the collection of 2 or more forces which are acting on an object or on a body simultaneously. Clear? Here, if this is our example, suppose if this is our example, here the body is subjected to 5 different forces. Now in this system there are 5 forces. Like that, if you take some other example where there might be only 3 forces, or there might be 6 forces, 10 forces, whatever it is. Here system is nothing but which is a collection of 2 or more. If there is only one force, it may not be a system because of their presence. Okay, but whenever there are 2 or more forces acting on a body, they are collectively called as a system of forces. Okay, clear? This is how we have to define system of forces. Nothing but it is a collection of 2 or more forces which are acting on an object or on a body simultaneously. Nothing but system of forces. Again, when we are discussing about system of forces, first of all, we have to consider whether they are coplanar forces or non-coplanar forces. Okay, when we are discussing about a system of forces, first of all, depending on their state of presence or depending on their directions, first of all we have to finalize whether they are coplanar or non-coplanar forces. Then what are coplanar forces? Then what are non-coplanar forces? Okay, first let me distinguish what are coplanar forces. Okay, here basically system of forces is subdivided into 2 different categories. First one is coplanar forces and second one is coplanar forces and second one is non-coplanar forces. First of all, we should know what is a plane. What is a plane? And based upon the presence of the forces, then we can distinguish coplanar and non-coplanar forces. Okay, in order to discuss about a plane, first of all we should know about the space. Okay, here I think all of you know about the space. A space is having 3 different coordinates. Let it be x, y and z. If you consider this space which is having 3 different coordinate axes, the first one is x-axis, second one is y-axis and third one is z-axis. Then in this particular space we will be having different planes. We are having different planes like xy plane, yz plane, xz plane. Okay, like that we are having different planes in a space. Suppose if all the forces which are acting on an object lies within a plane are known as coplanar forces. Okay, here if this is our example, here almost all the forces are acting on a single plane. Yes or no? Let us transform the same object into this coordinate axis. Okay, let me take here which is having different forces like F1, F2, F3, F4 and F5. There are 5 forces. Here I have transformed from here to here, here to there. Now if you look at the forces, here almost all the forces are present in a single plane. Therefore now this system of forces are known as coplanar forces, because here each and every force is present or lie in a single plane. Okay, this is an example for coplanar forces. And what is non-coplanar? Okay, if you understand coplanar, then you can easily define non-coplanar. Suppose if the forces are acting along different planes. Suppose a force is acting in this direction, along the z direction, or if some other force is acting in some other direction or in some other plane, then the system of forces which are present in different planes, in that case, then that is considered as a non-coplanar forces. Clear? And what is the possibility of having coplanar and non-coplanar forces? Almost all the practical problems are having only non-coplanar forces. Okay, what is the possibility of having coplanar and non-coplanar forces? Almost all the practical problems are having only non-coplanar forces. But as per our convenience, in order to simplify the process, we are assuming that the forces are present in a single plane. The forces which are present in a single plane for few limited problems. Okay, let me take another example. Okay, suppose when a truck is present on a ground, okay, when a truck is parked or when a truck is in rest condition on a ground, then here if you consider what are the various forces that are involved in this plane, here the weight of the truck is acting in downward direction, and also as a result of the contact between the wheels of the vehicle and road or ground, there is some reaction. Let it be, reactions are also just like forces. Let it be some F1 and F2. Now if you consider this particular truck as a unit, here it is subjected to three different forces. One is the self weight of the truck, which is acting in vertically downward direction, and also the reactions or the resistances caused by the road or the ground on the wheels of the truck, which are acting in the upward direction. Clear? Okay, when we are analyzing the truck, we are assuming that here almost all these three forces are acting along the same plane. But is it correct? No, because here almost the weight of the truck is acting along its CG, center of gravity, which may not be exactly in the plane of the wheels. Suppose if you take the truck which is having 4 wheels, okay, then here the weight of the truck is concentrated or acting along the CZ, nothing but it may be at center or it may be at some other location, but we cannot say it is always at the wheels. But here the resistance offered by the ground on the wheels of the truck are at these two planes. Now these two means F1 and F2 in a same plane, whereas W is in some other plane. If you take it as it is, if you take it truly, or if you consider it as it is, then W is acting somewhere in some different plane and F1 and F2 are acting in different planes. Now actually this is a non-coplanar system of forces, but if you consider it as a non-coplanar system of forces, our analysis will become quite complex. Therefore it is assumed as a coplanar force system. Then when we are assuming it as a coplanar system of forces, then what about the accuracy of calculation? What about the accuracy of values, or what about the output? There is no much difference in the output. Even if you consider the forces as non-coplanar or coplanar, there is no much more difference. only in such cases, we are going to consider the non-coplanar forces as coplanar forces. Clear? In almost all the cases, the forces present in a system are almost non-coplanar. But if you consider the problem as it is, our analysis will be quite lengthy or quite complex. Okay, in order to decrease the complexity or in order to make it simple, we are assuming that the forces which are present in that system as coplanar. But still, almost our values are same. There is no much more variation or there is no much more difference. Okay, that is why we are considering even the non-coplanar forces as coplanar forces in few cases. Okay, and next, here the coplanar forces are further subclassified into different types. Again, here the coplanar forces are further subdivided or subclassified into different types. Okay, first of all, okay, first one is collinear forces. Collinear forces, and second one is concurrent forces. Second one is first one is collinear forces, and second one is concurrent forces, and third one is parallel forces, and the fourth one is non-collinear and non-collinear and non-concurrent forces. Okay, this is how the coplanar forces are further subclassified. The first one is collinear forces, and the second one is concurrent forces, and the third one is parallel forces, and the fourth one is non-collinear and non-concurrent forces. Okay, then the first one is collinear forces. Here, suppose if the system of forces are present along a same line. Okay, again here I want to take an example. Suppose when a body is having a system of forces, it may be 2 or 3, any number of forces, but if all these forces are present or acting along a single line, suppose here it will be the first force which is acting over the system F1, and there is another force F2, and there is one more force F3. But here, if you consider the line of action or the direction in which these three forces are acting, here all the three forces F1, F2, F3 are acting along a single line. Then here the system of these three forces, F1, F2, F3 are known as collinear forces. Collinear, linear nothing but line. Here all these three forces are acting along a single line. Therefore, this entire system of forces are known as collinear forces. And the second one is, let us take another body again which is subjected to the same three number of forces, but here all the forces are acting at a single point. Let it be F1, F2 and F3. Again here the system is having the same three number of forces, but here all these three forces are present or starting at a single point. This is the point, or this is the point of action where all these three forces are started. But if you consider the line of actions, their line of actions are different. Here F1 is acting along this direction, F2 is acting along this direction, and F3 along the downward direction. Their line of actions are different, but they are started at a single point. This type of system is known as concurrent forces. Clear? Collinear forces are acting along a single line, but their point of action may be different. Here this one is acting here, the first force is acting somewhere here, and the second force is acting somewhere here, and third force is acting somewhere here. Okay, they are acting at different locations, but they are in the same direction. They are along the same line. Now, in the case of concurrent forces, the forces might be acting in different directions, but they are starting, or they should start at a single point. This is called as concurrent forces. And third one is parallel forces. And the third system is, and the third one is, okay, wait a minute. I will minimize the size. Okay, and the third one is parallel forces. Okay, then parallel, the name itself indicates if the forces are in the same direction, but they should not lie on a single line. Okay, parallel forces. Let us consider the same three forces, F1, F2, and third one is F3. Here if you observe the way the forces are acting, both F1, F2, F3 are acting at different points. Therefore, their point of application, or the point where the force is concentrated, is different. Here this is the point where F1 is acting, and this is where F2 and this is where F3 are acting, and their line of actions are also different. Okay, this is the line of action, this is the line of action of first force, and this is the line of action of second force, and this is the line of action of third force. If you look at the line of actions or the point of application, they are different, but their line of actions are parallel. Okay, here all these three forces are acting along a single direction, in the same direction, but they are not on the same line. They are on the different lines, but they are in the same direction. Clear? This is what we call as a parallel force. And the last one is non-collinear and non-concurrent. Okay, already you might be understanding what is non-collinear and non-concurrent forces. Nothing but the forces must be present within a plane, because all these four sub-classification is from the coplanar forces. Nothing but here everywhere the forces are present within a single plane. Okay, and the last one is non-collinear and concurrent forces. Non-collinear and concurrent forces. Okay. Okay, let us take the same three number of forces, F1, F2, F3. Here if you consider the point of application, F1 is starting here, and F2 is starting from here, and F3 is starting from here. Therefore, their point of applications are different. And even if you consider their line of actions, okay, this is the line of action for the first force, and this is the line of action for the second force, and this is the line of action for the third force. Now, if you check the fourth one with the all remaining three conditions, now in this case the forces are present within a single plane, but still they are non-collinear because they are not along a single line, and they are non-concurrent because here all these three forces are not started at the same point, and even they are not at all parallel because they are in the same different directions. Therefore, this is an example of fourth one, that is nothing but non-collinear and non-concurrent forces. Okay, with this I will close the session. In the next class we will continue. Thank you.